So our job in this example is to identify the single pair of resistors that are in series for each of the three example problems. So let's look at circuit A first. You can see here in circuit A there are 4 resistors, so there aren't that many possible combinations that could be in series. I could look, for example, at resistor R sub A and R sub B. Are they in series? Well, no, because the connection between RA and RB has a junction point. There's a branching point that's right here. So R sub A and R sub B are not in series. Similarly, R sub A and R sub C are not in series, nor are R sub B and R sub C. Well, that means that if we're going to have 2 resistors in series, it's probably going to be R sub C and R sub D. And sure enough, you can see that we can trace from R sub C to R sub D, passing only through wires and never having a branching point between them. And so therefore R sub C and R sub D are the pair of resistors that are in series in that circuit. Now this might seem like it's a really trivial skill, like we shouldn't need to spend this much time on it, but trust me when I tell you that really strengthening the skills of being able to recognize resistors in series and parallel will really pay off when the circuits get to be more complicated. Here's an example of a circuit that's more complicated. Just looking at this, R sub D and R sub E are not in series with one another because there's a branching point between them. R sub B and R sub A are not in series because there's a branching point. R sub A and R sub C are not in series because to get to them, you would have to pass through something other than a wire. You'd have to pass through a resistor. So you can see, for example, if I tried to go from R sub A to R sub C, well, I've now passed through another resistor. So those are not in series. So there aren't that many choices left. It turns out that R sub B and R sub C are in series because you only have to pass through a wire and there are no branching points. That means that you are 100% guaranteed that every microamp of current that flows through one of those resistors must also flow through the other one. So here we're looking at R sub B and R sub C. And now looking at this last example, this is similar to one that we saw in class, but I've added a couple of diagonal wires here. So I'm looking at some of these and let's see, there's the 4 ohm and the 3 ohm. No, see, the 4 ohm and the 3 ohm are not in series anymore because there's now a branching point right here. So some of the current that goes through one of those resistors could also go through the diagonal wire. The 7 ohm and the 4 ohm, not in series because of the branching point. 6 ohm is in series with nothing because of that branching point. The 8 ohm and the 5 ohm, no, there's a branching point that goes in several different directions there. So we're really reduced down to only the possibility of the 2 ohm and the 5 ohm resistor. Those are the only 2 that are in series in this circuit. And as you can see, any current that flows through one of those is going to have to flow through the other. So here we're looking at the solution being 2 ohm and 5 ohm. Those are the 2 resistors that are in series.